Okay, so in the previous video, I gave you a challenge to solve this particular problem in which you're given the initial states of nitrogen gas, initial volume and initial pressure, and the initial volume and pressure of oxygen gas, both at 273 Kelvin. Then you mix them in a 10-liter container. What's going to be the new partial pressure of O2 and N2 and the total pressure of the mixture once you put them all in a 10-liter container? So, I've already in the last video, I've placed already the given for N2 and O2 and of course the required at 10-liter volume. So the approach there is first, we need to be able to calculate for the N of N2 first and also the N of O2 because that's what we lack. We have temperature, volume, and pressure, but we don't know N2. N2's N, in which you can use ideal gas law to solve for that because you already have Vt and P. So N2 is just equal to the pressure of N2 times the V of N2, of course, because this is for initial, divided by the RT. And while the N of O2 is equal to still the same thing, same formula, but it's the P of O2 times the V of O2 over RT. Now, please make sure that you substitute the right values. For PN2, it is 2.00 atmosphere times the volume of N2, which is 24.0 liters, divided by 0.0821 liter atmosphere per mole Kelvin times 273 Kelvin. On the other hand, that's the same with for PO2, that is 2 atmosphere. Let me just not put the unit because the space is not enough. Then the volume is 12.0 liters divided by R of 0.0821 and then T is 273 Kelvin. Again, I did not just put the unit as long as you're sure that what you're substituting are the right units already. So putting them all in the calculator, you will get N for N2 to be 2.14 moles. And N for O2 is 1.07 moles. I want you to check this in your calculator if my computation is correct. So what is the next step now? Once you already got N of N2 and N of O2, then we can readily calculate for the partial pressure of N2 and O2 because this amount that we got here are the amounts that combined in the 10-liter container. So we use these amounts to solve for the partial pressure in which the volume becomes 10 liters. So let us now proceed. Let me erase now. Let me erase all of this. So now that we got N of N2, which is 2.14 moles, let me just put it here. I can now solve for the partial pressure of N2. So that's going to be P of N2 using ideal gas law. That's going to be equal to N of N2 RT over V. And the V that we're talking about here is the volume, the new volume of the container, which is already the 10 liters mixture. So putting that all in, so you put your 2.14 and then your R, and then the temperature doesn't change, it's still 273, then divided by your 10 liters. So now we get P of N2. So P of N2 in the 10-liter volume is 4.80 atmosphere. Okay, so that's what you get if you are getting the partial pressure of N2, which is the same process if we're going to get the partial pressure of O2. We use the one that we just got earlier, the 1.07 moles. So now we're ready to get the partial pressure of oxygen. Let me just make it in blue. So PO2 is equal to, of course, the N of O2, but R times T and the volume, the new volume, which is 10 liters. So we substitute that. That becomes 1.07 mole. That's the value we got earlier, times 0.0821 times 273 divided by 10 liters. So putting that all in the calculator, you would get 2.40 atmosphere. So now we got 2.40 atmosphere for O2. That's the P of O2. And we get um, P of N2, which is 4.80 atmosphere. Combining the two, we can already get the P total of the mixture, which is just adding the two pressure units. So that's 4.80 plus 2.40. Our total pressure is 7.20 atmosphere. So I hope that you got this when you tried this problem out. I hope that you're following through the process and in understanding that in this problem, once you're given like a situation in which the initial volume and pressure of each component is given prior to mixing, you have to separate them first, get their individual amounts, and that amount doesn't change when the two gases are mixed in a different container with a different volume. And we use the final volume of the mixture when we got already the new pressure of each gas when they are in the container. But prior to that, their pressures, individual pressures prior to mixing is still 2 atmosphere, but it changed. It became 4.80 and 2.40 atmosphere, which is expected to increase because the volume is lower than its initial volume prior to the combination in the 10-liter container. So I hope you understand this. You can leave comments if ever you have some questions on how this problem has been approached or whatever your questions that confuses you with the process. Please don't hesitate to ask questions in the comments below. I'll try my best to answer them. And I hope that you're getting this and please answer all the exercises that the teacher will be giving you. So this has been Madam Narca saying don't stop learning, relearning, and unlearning. Please like, share, and subscribe to my YouTube channel. God bless you all. Bye.